Yes, Ayush.
Good evening, sir. Good evening, sir.
Good evening. Here, your five topic is OMC, reaction mechanics, coordination, chemical bonding, and organic spectrum.
No, sir. Organic spectra, nahi, sir.
Solid.
Yes, yes.
Solid, yes. Okay, let me start. First of all, basic introduce yourself.
Yes, sir. Myself, Ayush AHER. I had done my 10th from PVSS Sainiki School, Loni, and my 12th from SHGM College, Kopargaon. After that, I had done my BSc from SHGM College, Kopargaon. So, so this was affiliated to the Savitribai Phule Pune University. And after that, I had done my masters from Dr. B.R. Ambedkar, National Institute of Technology, Jalandhar, and I had done my MSc project in enhancement of mechanical and durability properties of cementitious matrix upon incorporation with silica nanoparticle. And I had also qualified certain exams like GATE and Maharashtra SET.
Yes, good. Your name is Ayush. Yes. How do you feel about Ayush? Explain briefly.
Yes, sir. So the Ayush basically, basically in the Sanskrit there is a phrase Ayushman. So the Ayushman means the boy blessed with a long and the healthy life, basically.
Yes. Good. Next is your hobbies. Your
Yes,
hobby
yes.
is traveling.
Sir,
Yes, no?
yes, yes, yes.
Meeting with different people. Yes. Describe your
Yes,
hobby. How to use it in a day, week, and a month. Can you
yes,
explain?
yes, yes. Sir, meeting with the different people gives us the idea about how how the culture is different in the different regions, and their festivals are also different in the different region. So it help us to think beyond our box. So and my hobby is also traveling, so it helps me in the recreation, means it gives some change in the life, so that our life can be become happy and enjoyable. And meeting with the different people also gives us a chance for the different knowledges that they have. And also it helps in our overall development. Also it makes me happy.
Yes, good. Your native place is Nasik, Maharashtra. Yes. How do you
Yes,
feel
yes,
about your district and state? Explain briefly.
yes, yes. So the Nasik is the very beautiful city, basically. So so it is situated near the Trombakeshwar mountains. So the Nasik is also called as the wine capital of India. And and the the Nasik is also famous for its grapes. So away, only the 15-kilometer away, there is the Trambakeshwar, which is among the 12 Jyotirlingas of the Bhagwan Shiv. And and the King Ram, during his exile, he made Nashik as his home. And also the Nashik is surrounded by mountains on one side, and also the river name as a Godavari starts from the Trambakeshwar, which is only the 15 kilometers away from the Nashik city.
Yes. Yes, your MSc project is, yes, the beneficial of your project topic in our society, human life, real life. Explain 5, 10.
Yes, sir. Yes, yes, sir. So basically, I had done a project which was incorporation of the silica nanoparticle or the graphene oxide within the cementitious matrix. So here currently, if you look at the pozzolanic cement, so the currently in the market, the pozzolanic cement, that is currently in the market, which contain nearly about the 30 to 40% of the fly ash. But here we have increased the amount of fly ash. That is about we have mixed 50% of fly ash within the cement, so that the mechanical and the durability properties of the cement will get changed. So to increase the strength of the cementitious matrix, we have added the silicon nanoparticle and the graphene oxide. So it will help us to reduce the emission of the CO2 in the environment. Nearly the 5% of the total CO2 which is emitted from the cement industry. So it will help to reduce some amount of the some amount of the CO2 gas in the atmosphere. Also, the cement is made from the lime, and also lime and the clay. So it will also get finished by someday. So it will also help that these renewable things will last for the longer time on the earth, and also it will reduce the cost of the cement, so that we can build the larger infrastructure for the poor people. So it has a lot of importance in the development of the country, because the cement is actually used for construction basically.
Yes, good. Next is BRC, Bhava Atomic Research Center. How do you feel about BRC?
Yes, sir.
Explain
Yes,
briefly.
sir. Yes, sir. So the BRC is basically the Bhabha Atomic Research Center. So it is among the one of the premium institute within the India. So it is directly overseen by the Prime Minister of India, and the BARC focuses on the various research areas. For example, nuclear science, material chemistry, or the food science, or the health related issue. So its work is in all the different things. And in recently, the BARC has developed one ore which is used for the purification of the aluminium, which is basically prepared by the BARC only. And the main focus of the BARC is the production of the renewable energy from the zero CO2 emission, with the help of the nuclear power plants that are in India basically. So and basically before BARC, all the research work was carried out in the TIFR. So after that, to bring all this research in one umbrella, the government has formed the BARC, so basically to bring all the scientists together under the one umbrella.
Yes. Next is, why will you become a scientist in BRC? Explain.
Yes, yes, sir. Sir, the becoming scientist in BRC will be very prestigious for me, because BARC is among the one of the prestigious institute which is directly contributing to the development of our country. So working in the BARC will will help me to increase my knowledge, and it will be also a very great thing to use my knowledge of chemistry in the field of in the BARC. So I have interest in the chemistry. So using my knowledge in the BARC, so it will be a very great thing for me to use my knowledge which I am very interested in the research, sir, basically.
Yes, what the role of scientific assistant in BRC? Explain.
Yes, sir. Sir, the role of scientific assistant in BRC is basically the analytical work they have to do, and the mostly the nuclear energy work they have to do, sir.
What is scientist? What is the major responsibility of scientists in our country?
Yes, sir. Sir, the scientist is basically the person who thoughts for the mankind. So he innovates the new thing which will be helpful for the human life, basically. So currently, the scientist should be research on the things which will have some direct impact on the human life. So scientists basically innovate some new thing which is not present currently on Earth, or which is not in this world. So scientist has to always learn the new things, so to improve his knowledge. And the scientist should always have the mindset of questioning to the other, because with the help of the questions only he will improve his knowledge, and he can develop the curiosity, so that he can find the new thing. So I think asking question is very important if you want to innovate the new thing.
Yes. Suppose if you will be selected in BRC,
Yes,
how do you feel about after 10-15 years?
yes, yes. Sir, if I get selected in the BRC after 10 to 15 years, so it will be a very long journey, because 10 to 15 years are a very big time. So in the BRC, I will try to learn the new things and to reach at the higher position. And also, I will try to give something new to the BRC, which with the help of my knowledge, I will try to give my 100% to work in the BRC, and to do whatever the best I can do or give to the BRC, and I will try to go at the higher position uh, in this organization, sir.
Yes. Yes, suppose if you will be selected in BRC, what are the major
Yes,
challenges will you face in your daily life? So how will you
yes, sir.
manage them? Explain.
Yes, yes, sir. Sir, sir, in the BRC, basically, the job is basically the scientific assistant. So this job is different from the other jobs, basically, because in this job the person has to always learn the new things, acquire with the new technologies. So so I will try to learn the new things as much as I can possible, as much as I can possible, sir. I will learn the new things.
Yes, good. Yeah, next move on in chemistry topics. Yes, no? Yes, what the relation between chemical bonding and solid state? Explain briefly.
Yes, sir. Basically, the chemical bonding is basically the attraction between the any two particles or the any two molecules. Basically, for example, the HCl. So, which is formed by the sharing of the electron pairs between the two different atoms. So, so it is basically the chemical bonding, and the bond is basically formed by the electron cloud. But in the solid state, basically the compound is basically the solid, but in the chemical bonding is basically the whole study of the chemical bonds within the molecule. But the solid state also contains the bonds, but this solid state is somewhat different, because the solid has a direct applications, such as catalysis, or in any other field. So the chemical bond indications or the solid state, which we can explain with the help of the chemical bonding, basically means the properties of the solid state we can explain with the help of the chemical bonding. So here the chemical bonding also help us to know about the structure of the different molecules, basically. uh, so in the chemical bonding we see the covalent bonding, ionic bonding, or or the or the different types of bonding. And in the solid state we see the metallic bonding, the covalent bonding or the hydrogen bonding in the solid state. So, so this means I will summarize that the uh, the solid structure we can explain with the help of the chemical bonding basically.
Yes, good. What the beneficial of this topic, solid state chemical bonding in our real life
Yes, sir.
society? Point 5, 10 point.
Yes, sir. Sir, basically, if firstly I will talk about the solid state. So the solid state has the lot of advantages. Basically, so currently the lot of solid state batteries are also built. The lot of research is going on the solid state batteries. Also, the solid state is used in the catalysis. Basically, the ZSM 5 is used as a catalyst in the different type of the reactions. And here the solid, everything which is around us is made of the solid, whether it is amorphous solid or the crystalline solid. So the crystalline solids like uh, rubber rubber and the glass, which is having the different uses of, for the mankind. And now if you talk about the chemical bonding basically, so with the help of the chemical bonding, we can uh, we can give or predict the structure of the different chemical compounds, so how they exist, uh, the different properties of the chemicals, whether they are acid or the basic, we can tell with the help of the chemical bonding. Also the different petroleum products which are involved, which are there, we can also study about them with the help of the chemical bonding. So why the boiling point of some compounds are more than the other compounds, so we can also study with the help of the chemical bonding. And also why on branching the boiling point decreases, uh, and also if we are having the straight chain alkane fuel, so it does knocking in the engine. But if you convert that fuel into the branch fuel or the branch chain hydrocarbon, so it will prevent the knocking. So the chemical bonding also help us to convert the long chain hydrocarbon or the straight chain hydrocarbon into the branch chain hydrocarbon. And also the chemical bonding will help us in also the chemical bonding help us to know about the structure of the various compound like water or the ammonia. So why the water is having the more boiling point as compared to the other compounds. So it can also be explained with the help of the chemical bonding. And also if you talk about our life, so the DNA which are present in us, so they are also made with the help of the hydrogen bonding. Basically, the guanine and cytosine are attached to each other with the help of the three hydrogen bonds. So the hydrogen bonding or the chemical bonding is having the lot of application in our body also. The peptide bond, uh, which is which is which is in our body, which is formed with the help of the two different amino acids. It, it is also the chemical bond only. So the our body is also made up of the various biomolecules. So the chemical bonding has a lot of applications in the surroundings, or the various medicine which we take is also the application of the chemicals only, sir. All this we can study with the help of the chemical bonding.
Yes, good. Yes, what is metal defect? Now, how many types of metal defect? Or the main
Yes,
application
yes,
of defect in solid state?
yes, yes. So there are basically if you categorize these defects, so there are basically the two types of defect, which is first one is the stoichiometric defect. First one is the stoichiometric defect. Stoichiometric defect. And the second one is the non-stoichiometric defect. Non-stoichiometric defect. So here in the stoichiometric defect, basically the number of the cation and anion remains same in case of the solid state. So here basically, if we talk about the defect, the two main defects which are called as the stoichiometric defect are basically the Frankel defect and the Schottky defect. So these defects are mostly observed in the ionic solid. So if you talk about firstly the Frankel defect, Frankel defect. So here basically the size of the cation and anion. So here basically the size of cation is smaller as compared to the size of the anion basically. So we can see this Frankel defect in some solid like so here is any one of the solid, for example AgCl. We can see the Frankel defect in any of the silver halide because the silver cation is having the smaller size. So we can see here. So I can represent it as plus, minus, plus, minus, plus. So here what happened? The positive cation of the silver here leaves from its position and goes to the intestinal position, interstitial position, and one vacancy is created, which is occupied by the electrons basically. So in case of the Frankel defect, the density remains the same, but only the cation leaves its position. And another talking about the Schottky defect. Schottky defect. So in case of the Schottky defect, basically what happens? It is shown mostly by the compounds which are having the comparable size basically. For example, NaCl. So if you talk about the NaCl basically, so here what happened? So this is Na plus, this is the Cl minus basically. Na plus, this is the Cl minus. Na plus and Cl minus. So here what happens? The same amount of the cation and anion goes outside the crystal, for example. So the density of that substance get decreased when there is a Schottky defect. So there will be one vacancy which is of the anion, and the one vacancy that will be of the cation basically. And another one that is the non-stoichiometric defect. So here we can call it as the metal excess defect. Metal excess defect.
Yes.
In case of the non-stoichiometric. So in case of metal excess defect, so for example, if we take the example of the NaCl. So here is the NaCl basically, Na plus, Cl minus, Na plus, Cl minus. So if you pass the sodium vapors over this solid substance, so this sodium vapors will get deposit on the substance or on the solid. So it will it will create some bonding with the chloride ions that are present in the crystal. So this chloride ion will leave the crystal and will get on the surface. So it will create the vacancies in the crystal, and they will form the compound that is the NaCl, and they will leave the electron within the crystal. So here the density will get decreased here in case of the metal excess defect, and there will be some extra positive charge within the crystal basically. So this is basically the metal excess defect, and also yes, sir, that much.
Yes, good. Any limitation of this metal axis, metal defect? Limitation,
Yes, sir.
drawback.
Yes, sir. Yes, sir. So the drawback of basically the metal excess defect is so here the density of that solid get decreased here, but the good point is that it became the electrical conducting material. But if you talk about the its uh, drawbacks here, so here we cannot control that how much anion will go outside this system. So it will decrease the strength of that crystal basically with the help of the metal excess defect, because we are reducing the anions basically. So it will also decrease the strength of that crystal basically, because it will create somewhat a repulsion between the two different cations basically. If we remove this anion, so these two cations will be somewhat closer to each other, so they will show the repulsion. So there will also some decrease in the strength of that crystal, sir.
Yes, good. Next, what is Bragg's equation?
Yes, yes, yes.
What
So
the
the
main
Bragg's equation
equation in solid state?
yes, sir. So the main application of the Bragg's equation, sir, it is basically used in the X-rays, basically in the X-ray diffraction. So with the help of the Bragg equation, so its application is basically we can tell the type of solid, whether it is FCC, whether it is BCC, whether it is N center or FCC, BCC, or the primitive basically. So we can tell this with the help of the Bragg equation only. So it is its major application. So the the Bragg's equation basically here we use the X-rays basically in the Bragg equation. So there are some interplanar distances in the solid basically, which is made of the different interplanar planes. So there are some distance which we can take as a d between the two different planes basically. So here these are the X-rays basically. So it will get reflect from the surface, and this another X-ray will get inside this solid and refract from this surface. So here it is the glancing angle basically. We will name it as A. It is as a B, C, and D basically. So if you connect these 2 points, so this much is the extra distance that the X-ray B has to travel. The extra distance, which we call as MN, is basically the extra distance, and L basically. So the angle between these two will also be the theta, and here will be the angle also be the theta. So these two rays are basically perpendicular to each other, and this interplanar distance, we know this interplanar distance basically. So here we use the formula that is sine theta is basically opposite, that is Mn upon hypotenuse, which is ON basically. So we know that the value of ON is basically D, which is the interplanar distance. So we can use here D and ON, and ON is basically D and Mn. So we can also use that formula for the triangle here. Firstly, we use for OMN, and here we will use that for the triangle ONL. So here sine theta is basically Ln upon ON. So it is also basically Ln is equals to D. So here we know that Mn is equals to the NL. So here we can write as sine theta 2d sine theta is equals to Mn basically. And we also know that this distance is basically the integral multiple of the wavelength here. So we will give it as n lambda is equals to 2d sine theta basically. So if we given the values of angle and the wavelength of this X-rays and the order of the diffraction, so we can find the distance between the two interplanar planes, basically. The distance we can find.
Yes, good. What the main purpose of Bragg's equation in solid and chemistry? The main purpose.
Yes, so the Bragg's equation is basically used in case of the XRD, which is the X-ray diffraction. So with the help of this X-ray diffraction, we can tell the characteristics of the compound basically. So we can tell whether it is FCC or whether it is BCC or whether it is primitive type of the crystal. So basically we have to use the powder form of the solid state or the powder form of the crystal. So that we can give the clear interpretation of that compound basically. So this is the main application basically.
Yes, any drawback limitation of Bragg's equation in solid?
Yes, sir. So basically, if we talk about the limitation here, we can talk about its application here. Basically, if our solid, if we are having the solid crystal which is not in the powder form, then we have to use the technique which is called as the rotating table method. So in this, we have to rotate that crystal so that we can the X-rays can be सर मतलब उस पे X-rays मतलब सारे के सारे डायरेक्शन से पड़े. तो इसके लिए हमें उसे मतलब रोटेट करना पड़ता है सर उस मतलब सॉलिड को. So it is the drawback that we get the clear results when it is in the powder form.
Yes, good. Yes, next move on chemical bonding. Yes. What is the difference between base pair, BBT, MOT, Explain.
Yes, yes, sir.
Any uses?
Whisper. Yes, yes. MOT, whisper, VBT and MOT, na, sir.
Yes. Whisper,
Whisper.
VVT, MOT, VVT,
Yes, yes,
VVT, MOT.
yes. So the basically here the whisper is basically the valence shell electron pair repulsion theory. So it is the part of it is after it is introduced after the VBT basically. So with the help of the whisper or the valence shell electron pair repulsion, we can tell the about the correct structure of that compound. We can we can tell about the correct shape or the geometry of that compound. Here we can tell whether the lone pair will occupy the axial position or the equatorial position. That we will we can tell with the help of the whisper only. So the whisper here tells us that the lone pair repulsion is larger as compared to the lone pair bond pair repulsion as compared to the bond pair repulsion. So here basically if we are having any compound basically for example for example if you take any compound that is ClF3. So here we know that its valence shell has the 7 electron 1 2 3 4 5 6 7, and this chlorine will form this 3 electron will form the bond with the chlorine, and we are having here the 2 electron pair. So here is a very big question that whether we have to put this electron in axial position or the equatorial position. So here whisper tells us that we can put this electron in the equatorial position basically to minimize the repulsion, so that it will have the T shape basically. So here the angle is 120 basically, and here is the 90 degree. So the lone pair will try to remain on the equatorial position. And when we talk about the VBT basically, so the VBT tells us about how the how the compound is formed. So the VBT has introduced the concept of the hybridization basically. So in case of the VBT basically the uh, the molecules which are of the same energy basically hybridized to give the naive hybrid orbital, which tells geometries and the shape of that compound basically. So the naive hybrid orbital are of the same energy, uh, which are so the orbital which are directional will form the more stronger bond basically. And so here the VBT has given us the concept of hybridization, which is if we are having the compound with the sp3 d2 hybridization or the d2 sp3 hybridization, so it will be octahedral basically. It has been told us by the VBT. And here in case of VBT, firstly we have to know the magnetic moment. So with the help of the magnetic moment only we will find the unpaired electron, and then we will decide whether to pair the electron or not. And the VBT has also given the concept of the strong field ligand and the weak field ligand, but it does not have explained why does this ligand acting as a strong field, or why the certain ligands are acting as the weak field ligands. And also the VBT has helped us a lot in predicting the structures also. So if the compound is having the sp3 hybridization, we can tell that it is the tetrahedral, or if it is having the dsp2 hybridization, then we can tell that is the square planar basically. And but the VBT cannot explain some of the complexes, which is the Huggins complex, which was not explained by the VBT, which was Cu NH3 to 2 plus. Here the VBT was unable to explain. So this complex is basically the square planar complex, but the VBT was unable to explain it. And when we talk and here the VBT do not consider all the electrons basically. VBT only considers the valence shell electron. But in case of the MOT here, so MOT is basically so here MOT basically considers all the electrons. The VBT is the monocentric, which is only around the one nucleus, but the MOT is the polycentric. Here we consider the lot of nucleus, and the electron density is surrounded around this nucleus basically. So in MOT we form the what we call as the bonding orbitals and the non-bonding orbitals. Basically, the atomic orbital which are involved in the MOT, and the hybrid or the orbital after the mixing will be the same basically. The molecular orbital and the molecular orbitals after the mixing will be same in case of the MOT. So MOT has also also explain us why the certain ligands behaves as the strong field ligand, and why the certain ligand behaves as the weak field ligand with the help of the nephroxetic series. And with the help of the MOT, we can also tell about the bond order basically, why the certain compound exists and why certain compound does not exist, which we can explain with the help of the MOT basically. So here the paramagnetic behavior of the oxygen was also explained by the MOT basically. So MOT was the most advanced among all these two theories here. Yes. And in case of the MOT, we represent the bonding orbital like sigma 1s, and anti-bonding orbital like the sigma star 1s, sigma 2s, sigma star 2s. In this way, we represent the orbital basically. But in case of the VBT, we explain it as S basically, P, and basically this D. So it get mixed to form the hybridized orbital, that is sp3. For example, if we are having any tetrahedral complex, so it will form the sp3. So it is represented like spd, and it is represented like sigma 1s, sigma star 1s, like this. And the MOT was successful to explain lot of things which was not explained by the CFT as well as the VBT.
Yes, good. Any limitation of Vesper, BBT, and MOT? Explain.
Yes. Sir, if the VBT has the lot of limited, we were telling after with the help of this unpaired magnetic moment, we were finding out the unpaired electron, and we were telling whether the pairing will occur or not. And here the VBT has also not given us the correct reason that why certain ligand act as the strong field ligand and why certain ligand act as the weak field ligand. So here the VBT cannot also explain the Huggins complex basically, which is CuNH3 2 plus. And here the VBT only considers about the valence electron basically. So there were the lot of disadvantages or the lot of things that VBT cannot explain. And here when we talk about the whisper basically, which is the valence shell electron pair repulsion theory, if we talk about its disadvantages, so this theory has only talk about how the structure or the shape of the compound will be. So it has not given us any knowledge about other things. It has only tell us about the geometry or the shape of that structure, or only the VBT has tell us about the repulsion and the position of the lone pairs. They basically whether it is kept on axial or the equatorial. So the other things like the magnetic properties, bond order, or the formation of the orbitals or the bonding, that not been explained by the whisper basically. So 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 the whisper was very limited to find out the geometry or the shape of that molecule only. And when we talk about the disadvantages of the MOT basically, so the MOT has so the every bond basically shows some vibrations basically, but when studying the MOT has considered only the rigid compounds basically. So the MOT has not considered the vibration among the bonds basically, and also for the complex molecule or the polyatomic molecule, the explanation with the help of the MOT becomes more difficult.